All right, everybody. How are we doing? It's your boy. It's Joey. Hello. We're coming in loud and clear. Can you hear me now? I'm here. You're here. We're getting ready. We're going to kick this chapters to cook us today, okay? That's what the plan is, all right? Whoa, there's some light. All right. How are we doing, everybody? I need some coffee in my life. Almost drop kicked somebody last night at work. They were coughing up a nice lung all over me, and they refused to put their mask on. I love retail. I love it. 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 I don't. And I swear, I'm going to drop kick somebody. Sooner or later, I'm going to get in trouble for drop kicking a fool. Wear your goddamn mask, goddammit. Shit real. All right. So, yesterday was pretty good. I know we didn't get through all the way through. I'm looking on my boy Dork Chop. If you guys are out there, if you guys are watching my channel right now, make sure you hit up Dork Chop. It's Dork_Chop. He's a great dude, man. Hit him up. Follow his channel. He's real fun, dude. He's playing marbles right now. I'm on his channel right now, actually, playing marbles and trying to do this at the same time. I'm gonna what I'll do is maybe on one of my weekend streams that we don't do our studying, maybe we'll play some marbles for you guys out there. But if you guys are out there, make sure you give my boy Dork Chop a follow. All right, he's an awesome fella. All right, let me drop this down. All right, we're gonna get into we're gonna jump on CML. I mean, first though, we're gonna do a like we always do. We're gonna do a chapter review. All right, because again, yesterday, well, just I need to just beat up. I need to beat up this review on this particular part. So part 5 is something I really need to beat myself up on. That way I can get past it. That way we can get past it and we can move on. Like I said, we're almost done with the first book. We're almost done with the first book. I know it's been a journey, and it seems like part 5's taking some time, but sorry, I need coffee. Woo! I know part 5 feels like it's taking longer than it should have, but I mean, this is part of studying. Sometimes you get stuck somewhere, and you got to I'm trying to think of what I was doing. I'm just trying to make sure. Today's Wednesday, right? Yes, today's Wednesday. All right. I'm just trying to make sure I don't have something to do with college day. That's something I got to figure out how to balance too with this stinking overnight job. Is now that I'm sleeping during the day, well, I'm trying to sleep during the day, keep getting woken up for all kinds of craziness, but I'm trying to fit in where to do my college stuff. I mean, the weekend is obviously I work on the weekends too now, which stinks. But at least, I'm not obligating myself to other things over the weekend. So, over the weekends will be the time that I do some, probably most of my college stuff. But, all right. Without further ado, let's dive into this. Let's dive into this review, guys. Get my live one. Here we go. All right. Or the intermission. Which one? Yeah, the intermission one's nice. That way I can actually see. Let's go to the live scene. All right. All right. Let's get into the practice here. Let's launch the Pearson. I had something goofy going on my computer. Like I couldn't log into it when I turned it when I got it fired up just a minute ago. It kept on saying my password wasn't right. So hope nothing's goofy going on with my computer. It was funny. I was looking at I don't know if it's funny, but I was looking at motherboards for servers and stuff like that with using dual CPUs. I was looking at what was it? I mean, this is out of the realm of what I can even do right now, but just as like a food for thought, I guess, for my endeavors that I hope to take on. What was it? It's Supermicro. Was it Supermicro or something like that? Supermicro's motherboards. They can host the AMD 7000 or the 7001X or something like that, which is a 64 core dual processor. If I can hold 2 of those bad Larry, so we're talking 128 cores of CPU usage. The motherboard also had, I want to say, three PCI slots, so that would be 3 graphics cards. Also, I think it had like 2 of the smaller version ones. It also had 3 slots for the NVMe memory sticks as well. And it also had 16 slots, 16 slots for DDR4 RAM. Which I think that was the motherboard that dude on YouTube, Renix Tips, booted up a supercomputer that had like a terabyte of RAM on it or something like that. But that's what I want to do in the future. That way I can have his shibboleth amount of virtual machines running all at the same time. It'd be great. You guys will love it. We'll be cooking up the internet. Just cooking it. All right. Let's do 15, 16, 17. I know we didn't get all the way through 17, but I feel comfortable that we can handle it. And yeah, because this is where we're at, and this is where I was getting stumped on it yesterday. Now, how many questions did we get yesterday? Was it 60 questions or something like that? Or was it 23? Can't remember. Let's just do it. All right. Oh, you know what? I don't have. That's 21. What's that? Not bad. All right. Let me. I didn't get my Epic pen up actually. I'm trying to make sure. All right. Refer to the diagram. Based on the information displayed, what is the cause of the connected interface having the down state protocol? Ooh. I know. See, I don't like that. I know. Yesterday, I think this was a question that I was struggling with. So, what it's representing is here is the serial link. Okay. Now that's one thing I guess that I was getting stumped on because of I've been so focused around Ethernet and not so much serial. There are some differences between serial and Ethernet. So what it's stating right here is the channel slots, controllers, stuff like that. So on router 1, show controller serial 1-0, and then you have it's showing its information right there. And then you have over here on router 2, show controller on 1-1. Then you have the interface serial hardware on DDE version 3.5, and then clock frequency detect RX clock text clock plus and minus 10%. So what is going on is the timing on these, because these are connected via serial, they need to have synchronized timing between each other. This was one that I got confused on because I was looking here and I was saying, oh wait, they're not in the same, subnet to each other, but I guess if you were thinking about class A network, this obviously could be the network. 10 could be the network, obviously, and these can just be host bits. You know what I'm saying? The 10.10.1, the 20.20.2. Those can be actual host bits right there. I was looking at it as this was somewhere in here was the network, and then this was the host, and then somewhere in here was the network, and then this was the host, given the fact that they would be in different actual subnets. So no configuration in interface bandwidth, mismatch IP subnets, disconnected cable, no configured interface rate, clock rate. So what to go back, what the hell? I don't know what that is. All right, so to go back to this, what it is on this, there's no configured actual clock rate on router 1. So that was that answer to that one. So again, I don't like the fact that I kind of knew that from yesterday, but that's it right there. All right, let's get into the next one. All right. The exhibit shows the output of the show IP interface brief command on router R1. All interfaces listed in the exhibit should work under normal conditions and have worked in the past. Which of the following is the most likely condition that would cause the output in the show exhibit? So the exhibit shows the output of the show IP interface brief. Okay, so we know that. It's on router 1. All interface listers in the exhibit should work under normal conditions and have worked in the past. Which of the following is the most likely condition that would cause the output in the show? So what do we got? Serial link connected to having problems inside the telco supplying the clock signal. Router 1 has having problems. Does not have any other problems other than the fact that no IP address is assigned. The router on the other end interface uses PPP while the other one is HDLC. The switch port connected to the. Alright. So what are we looking at? No IP address is assigned. Serial 000 is administratively down. That's down. Up, down. Administratively down. Zero. No, that's just administratively down. Okay, so we're gonna eliminate that one. Our one 0/0/1 is having problems. There's no IP address. So down. So that's kind of true. There's no IP address on that one. So that's up and down. The switch port connected to 0/1 interfaces the interface has been shut down on the switch of 501. So the status is up, but the protocol is down. I'm kind of between this one and this one. Let's go with this. All right. So, on 501 is in the up down state, which generally refers to layer 2 problems. For the answer that suggests the adjacent switch interface shutdown, and that were if that were the case, R1 would not see any electrical signals on the cable, so R1 would instead place the interface in the down. So that would So that'd be in the down state, implying that the physical layer. Okay. 0/0/0 has the shutdown command configured, so there is no way to know whether the actual link has any layer 1, 2, 3. Yep. Okay, we looked at that because it had somebody administratively shut down that interface. 0/0/1 does not have an IP address assigned, but the lack of IP address would not cause the down status. So other problems, probably layer 1, exist. For 0/1/0, which is in the up-down state, implies a layer 2 issue. So the mismatch configuration is on the layer 2 protocol. And so let's look at 0/1/0/1. So yeah, so the protocol is putting it down on that one. So what's that implying is on the layer 2, on layer 2, that's where the problems are occurring. So there's some kind of misconfiguration on the layer 2. So on the OSI model, so obviously we have physical, so that's like the wires and stuff like that, and that would be implying that there's no electrical signal. So something as towards which one was it? So something towards like it being down, where it has no actual electrical signal. Okay, I'm starting to get to grasp where these questions are going. Okay, so remember, this is why we got to review these, because we got to make sure we're doing this. All right. Which type of router port is commonly used to connect an external modem so that an engineer can remotely access the device? So remember, it'd be auxiliary. All right. Auxiliary, that is for like connecting a phone line, quote unquote phone line, into the router, so that it'd be a port on a router that you connect the phone line into, so a remote engineer can access that router from via SSH or Telnet or whatever have you. Hopefully SSH. All right. Refer to the diagram. Which cable type is used in the reference location? So this is where I was getting stumped yesterday, because obviously you see this here. This is always the electric bolt right here. Type of symbol that is always representing like a serial line. Okay. The channel service unit and the data service units. Channel service units and data service units. Let me just want to look that up again, okay? Because I want to get this in my memory bank real hardcore, guys. Channel service units and data service units, right? Yeah, channel service units and data service units. A device that understands the layer 1 details of a serial link installed by a telco, and how to use serial cables to connect which network equipment such as routers. Okay, so these are the devices. Okay, these are in between devices from a telco company. Okay, to your actual router. Okay, and what's implying what we read was most modern day home routers and stuff like that. The channel service units and the data service units are embedded inside of your home router, so they're built inside of your actual router itself. So you wouldn't see a separate actual device, okay? Because those are separate. Those are combined entities now, okay? And what I got confused was thinking that an Ethernet cable was supplying that connection between when the devices are actually separate, okay? But it is still a serial connection between the channel service units and the actual physical router in this, for instance, okay? So we have serial links connecting to channel service units, serial links connecting to routers, okay? All right. Which command would enter an IP address on a router's interface? So remember, there's no subnet or mask subcommand at all, and this would be an improper IP address because there's no actual mask. Okay. On a Cisco iOS command that are typically used to view IP address interface information, which one shows only the address but not the mask information configured on the interface. Okay, so that would be the show IP interface brief. Okay, so the show protocols would show pretty much everything. All right. You are troubleshooting connectivity issues with a router. When you type in the command show IP interface brief, you notice that the status is administratively down and the protocol is down. What is the meaning of this information? The interface has a shutdown command configured on it. So another engineer went in and physically typed in the shutdown command on the command line, putting that interface in the administratively down state, okay, and also putting your protocol down as well. Okay. All right. PC1 just powered on and has not sent any frames into the network. PC1 has has a statically configured IP address and a default gateway configured out as the router 501's interface. So has the default gateway is configured as the 501's interface. Okay. PC1 sends the ping to 172.16. Oh, this is something I want to look at in CML today too, because packet tracer, if you remember, packet tracer on those packets. Okay, now this is the issue with packet tracer. Okay, this is why sometimes you can't go off 100% off of packet tracer, because sometimes packet tracer is not 100% accurate. That's why we kind of have CML up here today, and we're going to be making a new lab up in CML today, doing some cool stuff. So I got that up. Cause so if you're not familiar with network emulation tools, Cisco Modeling Lab is the well, at least for me. I'll get into arguments with other people about EVA, EVNG. I don't know if I ever pronounced that right. I don't use it. I've never used it, but I don't. It's not like I have to because I have everything else. But so you have that GNS3. I do sometimes play in GNS3. Again, I use the web-based HTML GUI for it, not the actual software program. I use the VM for it. I think it's great. It's a lot better than using, for me at least, in my opinion. It's a lot better than using the program and the VM at the same time. All right. But so I kind of strictly stick with Cisco Modeling Lab because Cisco Modeling Lab is the it's what it's so to use Cisco images inside of EVNG, inside of GNS3, you have to, okay, if you want to be an upstanding person, an upstanding citizen, you should have purchased Cisco Modeling Lab. So my whole thing is, if you purchase Cisco Modeling Lab, why not just use Cisco Modeling Lab? It's great. It's awesome. It's amazing. And it's, in my opinion, it has all the tools already there, and it's getting better and better and better and better and better. And there's a whole team behind it that are focused solely on making sure that it's going to be the greatest network emulator tool out there. I honestly feel it will be soon. So enough on that rant. So PC1 sends a ping to 172.16.0.33 and gets a reply. What dynamic ARP entry should appear in the ARP cache on the various network devices? Now, this is where well, I guess this wasn't such a packet tracer problem. This was just a me problem, because what I assumed is when, I guess this was a little bit of a gap in my knowledge. So when PC1 here pings PC3 here, that was awful. PC3 here, it's going to send a ARP message out, okay? The address resolution protocol, okay? ARP, okay? Address resolution protocol. It's because it doesn't know the MAC address information of PC3. It may know the layer 3 information, the IP address of PC3, but it may not know the actual layer 2 information, the actual MAC address. So what I assumed is PC1 was going to send that ARP. The ARP would go through the router. The router would forward it out to 501 and send it as a broadcast out, to see who has the MAC address for 172.16.0.33, and then that ARP reply would come back, go through the router, come back, and then it would go back to PC1. Okay, but what really happens, and this is what, again, this was my gap of knowledge was, is when PC1 sends that ARP goes to that router's interface, the 501. Okay. Now, what happens is then if the router doesn't know PC3's information, the router itself will send an ARP out. Okay. The router itself would only hold the MAC address information. Okay. It would only hold the MAC address information in its own ARP table, and it's in it here. Okay. It would only be storing that ARP messages inside of its own ARP table. Okay. Inside of the actual router. That ARP data will not go back to PC1 over here, nor will PC3 know the layer 2, the layer 2 information of PC1. Okay, it's kind of like, I guess, like a security feature built into how these routers and stuff work. So, all right. So, PC1. So, you would have 001 in the what dynamic ARP entry would appear in the ARP cache on the various devices in the network. So it'd be 00, it'd be like all ones in the router's ARP table, okay? In the router's ARP table, okay? All right. I know that question is a little foggy, but that's it right there. Try to stop down some of my dinner too at the same time. All right. So host B issues a ping command to host D. IP address. The ping command succeeds. Which of the following statements is true regarding the ICMP echo request sent to host B? All right, where are we at? Let's identify some hosts. So we got host B over here and host D. Okay, where are we going? All right, so we're going here. All right, then we're going through a serial link to router 2. Router 2 is then going to pass that along to switch 3. It's going to go through a hub and down to the actual host. Okay. All right. So what are we looking at? So we need to select two answers. So the frame holding the packet as across the cable between switch 1 and switch 2 has the destination MAC address of router 1. Hold on. Let me read that again. The frame holding the packet as across the cable between switch 1, let me get my pen out, switch 1 and router 1 has the destination MAC address of R1. So that is actually, I think I'm gonna go back and select that one. Okay. The frame holding the packet as across between the cable between S2 and S1, S2 and S1 here, has the destination MAC address of switch 1. No. We're now going to select that one. That's a big no-no. The frame holding the packet as it crossed the cable between router 1 and the local channel service unit, data service unit, has the destination MAC address of the R2 serial MAC address. I don't know. Put a question mark there. The frame holding the packet as it crosses the cable between router 2 and switch 3 has host B's MAC address as the frame holding the packet as across the cable between router 2 and switch 3 has host B's MAC address? No, it doesn't. So that's a big no. The frame holding the packet as across the cable between switch 3 and hub 1 has the MAC address of router 2 as the source. And that is a big yes. So, okay. All right. Because remember, when these packets, so B is going to send it to the B when B encapsulates that IP packet inside of an Ethernet header and trailer. It's going to inside of that Ethernet header and trailer. It's going to have it as router R1's MAC address. Okay. Now, when that's encapsulated again, it's going to go through it's going to get put into, because it's going over a serial link. Okay, so that's probably like a high level data link control header and trailer. Okay, so that's going to be encapsulated in that type of a frame. All right, which is going to be sent from R1 to R2. Now, when R2 again de-encapsulates and re-encapsulates that IP packet again inside of a Ethernet trailer, now it's going to have it as the source MAC address. Okay. All right. This one and this one. Right. All right. Very good. All right. All right. So, in the internetwork shown in the diagram, R1 is the central site router for R2. So R1, let's write this down. R1 is central site, central site router. All right. R2 is typically remote, so this is the remote. Okay. The network manager dictates that all routers should all use a default route to forward packets. But the central site, while the network manager dictates that all remote routers should use a default route to forward packets back to the central site, while the central site router should use a static route to forward packets to each remote office, local area network subnet. As soon as the network manager has correctly implemented the design, you connect to R1 and R2 using Telnet to issue the show IP route command on each router. Which of the following answers list the output you should see in the routers? All right, so if you remember, so the default is going to be the 0.0.0.0.0, all right, with the subnet mask of 0.0.0.0.0, okay? So this would be the, and it's probably going to be going out of the, it's going to be placing it at the serial 0.0.0 interface, okay? So this would be what the remote sites would be using. So it'll be using the all zeros, blasting it out the the serial interface, okay? All right. Do we have something like that as a option here? And we do. We have it right here. All right. So let me. So I'm gonna, because we gotta select two. We gotta select two answers for this one. All right. Let me just jump over here real quick. Put this here. So I can just monitor chat at the same time, just in case somebody's chatting it up. I don't want to miss. I don't want to miss a thing. Come on, connect the chat. All right, there we go. All right. This might actually be a better way for me to do it from now on. All right. So, all right. So we have that option here. All right. We have the option here. Now, the central site though is being dictated that it needs to the central site should use a static route to forward packets to each remote office local area network. So here's pretty much our local area network right here. It's on the 172.176.66/26 IP address. Okay. So this right here is what's been identified as our local area net, the remote site local area network. Okay. So what kind of options do we have here? So what do we got? And we have that. So we have this option here, which dictates that it's in the same subnet, and it's via this interface, well, this IP address on our remote router. All right, so let's go. We're gonna go with this option and then this option right here. Okay. So let's select those two. All right. Let's see if we're right. All right. So we were right on those. Okay. All right. All right. Refer to the diagram. Which static route statement on router 1 should be on router 1 would be configured to ensure that okay, all normal devices traffic going from 30.30.30. All right, so this network right here. All right, all normal devices traffic going to 30.30 would be routed via the primary path. Primary path being this path right here. All right, so from the all 20s pretty much instead of the all 10s. Okay, so the all 20s. All right, via the primary path, and all traffic going to the server A. So server A would be routed in the high priority, so going via the all 10s. Okay, so let's take a look. Let's take a look. Let's take a look at our what up? How we doing out there? DI Rome. I'm doing good, my friend. Welcome to the channel. If this is your first time, so what we're doing, if this is your first time to the channel, it might be because I don't recognize your name. What we're doing is we're about midway through our studies for our CCNA certification. So CCNA stands for Cisco. All right, so like Cisco networking, not Cisco the food company, but Cisco networking. Cisco Certified Network Associate certification. Nice. I'm glad to have you here, DI Rome or D Rome. Yeah. So if you're familiar with anything networking or IT related, you may have heard of the company Cisco. What I'm going after is pretty much this right here, which is a associate certification for it's associate certification for their like entry. It's like they do have like a junior certificate. This is like just like the next step up. It's still fundamental though, super fundamental. But the cool thing is it covers the CCNA covers a huge scope of just networking fundamentals and everything. And it from here you can pretty much branch off from so many other different IT related things. I'm an IT engineer for Costco Rico. I'm looking forward to learn with you because Cisco is one of my IT areas I need to improve. Oh, really? Yeah. Oh, no, snap. That's awesome, dude. You pump me up right now. You pump me up. So that's awesome, man. Yeah, dude. So, all of my stuff. So, I mean, if you just jump in now, you can, and if you have the fundamentals, if you're already in the IT, you could probably just jump in right now where we're at. So right now we're in the we're in part 5 of the actual OCG. So this is the official cert guide here. We're in part 5, which is covering IPv4 routing. And the part of where we're at right now is IPv routing over LAN, so local area network devices. What we were doing last night in the stream, we were going over the router on a stick topology. We were going over switch virtual interfaces and how to route between and how to configure VLANs and route on a layer 3 switch via that way. And then we kind of ended on layer 3 Ethernet channels and routing on Ethernet routing ports. So Ethernet channel routing ports. I kind of ran into an issue with Cisco. I don't know if you're familiar with any of the like simulators. Yeah. So I don't know if you're familiar with like Cisco Packet Tracer or anything like that. I use a various amount of different things. I use Cisco Packet Tracer. I use Cisco Modeling Lab. I use GNS3. If you know anything about either one of those things, you'll know that Cisco Packet Tracer is a simulator. So it's just like a simulation of what these things could do. No, not yet familiar. Okay, so I'll give you kind of like the skinny and easy of it real quick. So this right here is Cisco. Yeah. So it's pretty much tool. So this right here, what you're seeing right here, this is Cisco Modeling Lab. Okay, now this is an emulation of the actual ISOs that the networking devices use. So this is a virtual machine that I'm running off of my server. So I have an ESXi server here, all right, and I am virtualizing this. This is a CentOS based virtual machine, and what it's doing, it's running these ISO images. All right, these ISO images. So these are actual. So this right here is all layer. This is their Cisco's iOS VL2, their virtualized switching image. So this virtual machine is running those images off of a KVM. Okay, and I'm doing multiple layer virtualizations to make this work, but it all works pretty well. I also have, so even though this says Cisco Packet Tracer, you can run Cisco Packet Tracer off of just your PC. It's just a program. It's not an actual emulator, so you don't need to virtualize anything. I run a Windows virtual machine though to run Cisco Packet Tracer, just because I have run into issues where Packet Tracer has actually crashed my computer. So the thing is I run it off of another VM because I'd rather have it crash the VM then have it crash my computer, especially while I'm streaming. So that's why you'll see me running Cisco Packet Tracer off of VM. I don't need to. I can run it off of my base computer, but I prefer to run it off of an actual VM. So, but today though, because I was running into issues with the simulation portion of Cisco Packet Tracer, because it only simulates what these devices can do. I need to have a way to actually know what these devices are doing. So that's why we're over here in Cisco Modeling Lab today instead. Cisco Modeling Lab, again, it's a virtualized, it's running everything virtually, so it's a little bit heavier on my PC, but my PC runs it perfectly fine. There's no issues with it. It's just yesterday I was doing a whole bunch of stuff in Packet Tracer. Okay. All right, so you're getting the gist. All right. So let's get back to, so this is the Pearson's test program right here. Let's finish up. I only got, I got 11. I'm at 11 out of 21 questions right now. And then we're going to dive into the actual book here. So we're going to go over, we're going to finish up chapter 17, IP routing in a LAN, local area network. And where we ended up last night, and I should have bookmarked it, but we ended, all right, we ended here, VLAN routing with layer 3 switch routing port. So that's creating Ethernet channels on a layer 3 switch, and turning that Ethernet channel into, I gotta update that on Nightbot. Yeah, I gotta update my actual thingy. It's supposed to say, I changed my times to 5:30 to give myself a little bit of a buffer zone, because I was running into issues being at 5 o'clock. So, but back to the subject in hand. So what I need to do is on Cisco Modeling Lab is we need to create an Ethernet. We need to get a layer 3 switch booted up, create some Ethernet channels, and then route and create those routing ports. I could not, well, again, Cisco Packet Tracer can only do so much. So nothing against Cisco Packet Tracer, I love it. So, all right. Let's let me pour some coffee real quick. Coffee. I love coffee. All right. So, refer to the diagram. Which static routes segments on our run would configure to ensure that. All right. So we're gonna select 2 answers here. Let's look at what we got. So IP route 30.30.10 2525 via 10.2. So okay. So that would get us here. Okay, to here. So this one is probably right. 30.30.30, 2525. Oh, wait. I'm not. Oh, hold on. We might have an issue. I'm not looking at this right. All right. So this is wrong. That's wrong. Because look at the mask. The mask is all kinds of funky on that one. So that one's wrong. All right. IP route 30.30.30. All right. So we have the correct mask on this one, because this is where we need to, this is where we're trying to get to. So, so here, all right. So this one most likely is right. IP route 30.30. So this is wrong, because this is a wildcard address, not an actual subnet mask. And IP route 30.30.30.100 via, so 10.10.2. All right, so let me get my eraser up. I know this one's wrong. This one's giving me, all right. Let's go with this one, and this one right here. All right. Boom, and I was wrong. All right. So the two different static routes needed required also all routes normal traffic to specific traffic design. The first corrected IP the mask matches all the designated between 30 to 30, while the octet value. All right, I kind of see. So I guess where I went wrong. This is where I was kind of getting stumped because of this crazy subnet mask. So when I see this subnet mask, that implies that this whole thing is network. Okay, which I'm figuring somewhere in here there's got to be some kind of host bits in here, and I'm figuring that this is where the host bits are residing in this 100. But I guess it is. It would imply that this is wrong because of the fact that again, it's getting confusing. The way they address some of these questions, for me at least, it gets confusing sometimes. So you wouldn't generally. How do I explain that? So if you would look at your IP routing table, you would see the /32 as the IP route, and not generally the all zeros. So, man, again, this is why we got to review this, because we really got to step our knowledge game up. So, all right, let's go on to the next one. Refer to the exhibit in the diagram. Which static route statement could you add to the central router to ensure that a default route always exists in the routing table regardless of the interface? So this is going back to OSPF, and does it state OSPF? No, it's not stating OSPF, but we want a default always to exist on the routing table. Okay, so where's our central? This is central right here. Default route. So we'll say the all zeros. So the all zeros, that's like the almighty default route. Yeah. So we'll say the all zeros, which is the almighty default route, going to the 192.168.1.1. So refer to the diagram. Central site router ensures that the default route always exists in the routing table regardless of the interface status. Okay. So yeah. All right. So this is representing the internet service provider, and we always want to make sure that no matter what, we're always pointing towards the 192.168.1.1. So we're going to select the almighty zeros default route at that permanent IP address. All right. All right. So we were right on that one. All right. Let's keep it moving. Refer to the exhibit and the figure. A branch office is going to be using Ethernet WAN links as a primary wide area network link with a serial point-to-point link as a backup. The designer uses OSPF over Ethernet WAN link. What command enables you to configure a floating static? Okay, floating static. There's some terminology. Floating static and OSPF. All right. So OSPF always has an administrative distance of 110. All right. So OSPF. All right, always has an administrative distance of 110, okay? What command enables you to configure a floating static on the branch? So branch to 200 dash point 0 in the subnet mask 24. So where are we going? So here is our actual. So it's off. So here's our central site, and here where we're trying to go. Here's our backup. What should the network should link fail? Okay. clean up the board a little bit. All right. IP route 200 200 200 255 255 dot 2 to do. All right, let's look at the exhibit because I need to know what's our backup. Backup off of that is, let's write this down a little bit. So we're looking at 150, 150, 150, 152, 50, 150, got 1 / 24, and that's off of the serial 0-1 interface. All right. All right, so if that's the case, that's our backup. So this one is actually looking pretty right because again, we want to assign a floating address. So we want to give it a value greater than 110. All right, so this one would be wrong. This one would be wrong. All right, and then 100, 100, 100 dot 2. All right, where's that address? So no, because that would be over this link right here. So that would be improper because if what it's stating is if the Ethernet link right here, the 501 to 501 at the central, if this link was to fail, then the backup over this serial link from serial 1-0 to 1-0 to the central backup, this has to then take over if the 501 was to fail. So then it would be relaying messages back over this Ethernet channel right here, okay, back to the central site. Okay, so this would be improper because that traffic would be getting sent this way instead of this way. So we're gonna go with the first option here. All right, we were correct on that one. All right. Which two steps must you perform to enable a router on a stick on a router's sub interface? Okay, so we need to select 2 answers. All right, we need to select 2 answers. We need to select 2 answers. All right. Configure the sub interface with an IP address. That looks pretty good. Speed and duplex full. We don't really need to worry about that. Configure the IEEE 802.1q encapsulation for the VLAN. Configure the IP route to the VLAN. No. So you need to first on the sub interface. You need to identify the actual. You need to identify the actual VLAN that you're going to be trunking to that switch. And you're going to be using the IEEE 802.1q encapsulation protocol to trunk. Okay, that way when that router gets those frames, those packets, and then when it sees those tags, those 802.1q tags, it understands first off what those tags are, and secondly what to do with those 802.1q tags. All right, so that's why we have to configure the 802.1 encapsulation for the VLAN, and then we also have to configure an IP address on that sub interface as well. All right, so let's go ahead and select these 2 right here. Keep it moving. All right. Which Cisco iOS command uses the 2960 switch to change the switch forwarding ASIC settings to make space for the IP routing? So that would be the SDM prefer IP routing. Let me just see if I can find the actual SDM, what it actually stands for real quick. I would like to know, because it didn't actually state. Oh, cool. I'm glad you're understanding. SDM. So as a network engineer, what kind of things do you do, Di Rome? What do you like? What is your scope of responsibilities? I guess. Yeah. So what is like the scope of your responsibilities? Is it managing like routing tables? Um, is it handling like I'm how's this? I haven't worked in IT yet. I since what had happened was in back in February of last year, I ended up getting injured pretty bad and being hurt up for a while. I lost my job. I'm a heavy equipment operator by trade, um, but since then I've had to switch careers because physical work is kind of out of my it's kind of out of my realm for the rest of my life now because I got to be concerned about my back and whatnot. So since I haven't really per se worked in the real IT field, I'm always curious to talk to IT professionals on to know what like the day to day of their scope of what their responsibilities are and whatnot. So yeah, I would love to know what you would what an IT engineer would normally do on a day to day basis. All right, SDM. Let me see if I can find SDM. SDM. I can't find it. Server admin, technical support, budgets, IT internal controls. I'm not into routing too much. That's why I need to improve. All right, I get you. So your servers are they all Linux based? Are they all Linux based servers? I've been doing a lot of because of where I want to take my education into the next part of my education is going to be into the DevNet realm, which is going to be um, like automation and stuff like that. I've been working on my Linux skills, Bash skills, Python and Ansible, and stuff like that. You know, um, I've I've got this. So in here, I've also got a virtual. I made a virtual. So this is EXXI. I don't know if you've used EXXI or Proxmox or something. I guess yeah, Proxmox would be similar to ESXi. But I've created a virtual switch inside of my actual server, and yeah, so I created a virtual switch inside of my actual server here, and this NX router right here, which is this image right here. This is PF Sense. So this is a PF Sense image. Obviously, it's an Ubuntu-based Linux image right here. I use this image to do a lot of my Linux labbing in it. So I created a DHCP server inside of that actual virtual switch. Obviously, because I didn't want it to interfere with my actual my home stuff. So that's why I had to break it off. But this NX router right here, what it's doing is it's doing that in a couple different directions. So I have it obviously I have it doing that to network address translation to then get out to the real internet. And then I have this Ubuntu. This is just the Ubuntu server image. This is the Ubuntu, I believe it's the 20.04 image. I have this acting as a DHCP server for a couple other VMs. I got a Fedora VM that's hooked in it. Well, this is all so these are all the VMs I actually have in that actual virtual switch inside of my EXXI server here. And this is where I do a lot of my Linux lab and stuff like that. But yeah, so that Linux is going to be on my next. Well, it's not on my next. It's in current to what my studies and all that are doing all at the same time. Oh, I was wrong. It's close. SDM preferred LAN-based routing, not NSA, not NSDM prefer IP routing. Ooh, all right. All right, let's imprint that in our memory bank. So it's SDM prefer LAN-based routing, not SDM prefer IP routing. Okay. So local area based routing. Okay, I guess that makes sense because it's only doing it's not doing routing over the wide area network. It's only doing network between the local area network. All right, that makes sense. All right. Refer to the diagram in the exhibit. Hold on. All right. Refer to the diagram. Refer to the diagram in the exhibit. An engineer is checking the work on checking the work of a coworker who is responsible for developing the router on stick configuration. Of R1, which options are true of the potential configurations of R1? So we got R1 over here. We have it's got shrink that down. It's got some so you got gigabit 0-0, 0.10, 0.200, and so it's got its sub interfaces for VLAN 20, 30, and 40. So we got VLAN 20, 30, 40. All right, we have our native. So it's stating that the native VLAN is VLAN 30. Okay, that's fine. All right. So let's look at so we got to select two instances. So let's look at our configuration here. So that's cool. All right, we got some. Look at that again. 30. 40 to 40, 40 to 30 to 30. I don't like the way they did their IP addressing though. It's so I wouldn't have done I would have done things a little bit differently. Maybe this, let's take a look. Yeah, the way they did all their thingies, I don't like it. All right, the mismatch VLAN ID and the sub interface numbers will prevent the mismatch VLAN ID and the sub interface numbers would prevent the trunk. No, the sub interface numbers do not matter. Remember that the sub interface numbers do not matter. All right, the interface handling the VLAN 30 and VLAN 30 has their assignment command reversed. Possibly. Ooh, wait. I think I'm seeing something. Right there, 0.200. All right. So this one right here, the interface handling VLAN 20 and VLAN trunk has their assignments command. So this one right here. So that one's wrong. So that one's definitely one of the answers. The VLAN assignment commands are all using the wrong syntax. The physical interfaces has a command that is invalid. Physical. So this is the actual physical, and you don't need over the physical. You wouldn't generally put the encapsulation.1q on the physical. That would just have to be on these sub interfaces here. The VLAN assignment commands are using the wrong syntax. No, that's right. All right, let's go with this one right here, the physical interface, and see what's happened. So, yeah, but see, this is why I don't like the way it's questioned something sometimes. Because, I mean, VLAN 40 could have had this IP address, and that's fine. VLAN 30 could have had this IP address, and that's fine. That doesn't matter. What matters is this right here for when the statement pretty much says that 200 should be represented in VLAN 20. All right. Oh, okay. I see where that went wrong. I had it backwards. Wasn't 20, it was 30 and 40. That's where I had it wrong. Oh, I knew something was mixed up here. All right. No big deal. We kind of knew where we went wrong, but all right. All right. When you are configuring routing ports on a layer 3 switch, what do the physical interfaces act as? When you are configuring routing ports on a layer 3 switch, what are the routing ports acting as? When you're configuring routing ports on a layer 3 switch, what do the physical interfaces act as? They're not switch port interfaces. They're not layer 2. It's between a switch virtual interface and a layer 3 interface. I'm going to say a layer 3 interface. And we were right. So we were right on that one. What is the purpose of configuring multiple switch virtual interfaces on a layer 3 switch? To provide layer 2 connectivity to the switches? No. To support routing between subnets residing on local VLANs? That's kind of right. To convert VLANs into subnets to provide reachable IP address to remote? No. To support routing between the subnets residing on local VLANs? All right. Which of the answers list a configuration step on a Cisco access switch to support IP routing using only switch virtual interfaces? Which of the answers list a configuration step on a Cisco access switch? So Cisco access switch, all right, to support IP routing using only switch virtual interfaces. Select 3 answers. So let's take a look at what we got for some information here. The VLANs associated with the VLAN interface must be configured and active. Each VLAN interface must be configured with an IP address. That one might be right. Each route physical interface must be configured with an IP address. The switch is enabled with IP routing. So I know this one is definitely right. VLANs associated with the VLAN interface must be configured and active. That's sort of right. Each VLAN interface must be configured with a IP address. So we're looking at which answer lists a configuration step on a Cisco access switch to support IP routing using only switch virtual interfaces. Each routing physical interface must be configured with a IP address. I'm going to go with that one. We might be wrong, but I'm going to go with that one. We're going to select 3 answers. Each physical interface must be configured with an IP. All right, we were right. All right, refer to the diagram. Refer to the diagram. Which Cisco iOS command would be configured on router R1's gigabit 0-0.300 interface so that it handles all non-marked traffic from VLAN 300. Refer to the diagram. Which Cisco iOS command would be configured on routers 300 interface so that it handles all non-marked traffic on VLAN 300. All non-marked traffic on VLAN 100. So we want all unmarked traffic. So we want to identify the encapsulation .1Q 300 native. All right. We want to specify that as the native VLAN. Okay. All right. which Cisco iOS command can be used on a router to view the different VLANs that have been configured into the router on a stick configuration. So that was the show VLANs command. And this was another command that using Cisco Packet Tracer last night, this command was not available inside of Cisco Packet Tracer. So that's again why we're using Cisco Modeling Lab tonight. All right, so we can do some of that stuff. All right, let's see how we did. We got a couple wrong. We did get a couple wrong. We still passed. We barely passed. But we got a couple wrong on it. So we need to review. Let's just do a quick review of what we got wrong. So the exhibit shows the example shows the output for the show IP interface brief command on router 1. No, so that one. All right. The exhibit shows the exhibit. Let's just go back and review the ones we got wrong real quick. The exhibit shows the output of the show IP interface brief command on router 1 R1s. All interfaces listed in the example should work under normal conditions and have worked in the past. Which of the following is the most likely condition that would cause the output in the example? So what it was stating is on the serial 0-1-0, as you can see under the protocol tab, the status tab right here is stating up, but the protocol tab is stating down, stating that we have some kind of misconfiguration somewhere on a layer 2. Right? Hell yeah! It's all about passing, baby. Thank you, man. You pump me up, D-Rome. You pump me up. So what it was stating is there was a layer 2, so we had a layer 2 possible misconfiguration here. All right, so let's go back to the exam now. And let's see what else we got wrong. So referring to the diagram, so this was the other one that we got wrong, that we had chosen the all zeros subnet mask when we should have chose the broadcast subnet mask. Yeah, the broadcast subnet mask of the default route to 30.30.30.100. Instead of this all zeros subnet mask. Then the other two we got wrong. So this was the SDM preferred LAN-based routing. Suddenly there is too much. Is there too much lag? Let me see. Hold on. Let me look at my statuses. But if it continues to happen, just tell me again, and I'll take a look at what's going on with the stream. You got it, D-Rome. Sorry about that. Yeah, I apologize for that, big guy. But you be good. Thank you very much for stopping by today. I appreciate you hanging out with me for the time that you did. I will catch you later. Be good, my friend. All right. So we're going to go with the SDM preferred LAN-based routing. All right. Let's review. There's one more that we got wrong. And it was this one right here. All right. All right. So we're good. We're back to we went back, we reviewed the ones we got wrong. I kind of understand where I was getting those other ones wrong. And just to reestablish that into my memory bank here. So, all right, let's close out that for now, and let's jump back into Cisco. Let's jump over to the chapter review here, and what we're going to do is we're going to, as we're finishing up chapter 17, we're going to jump over to Cisco Modeling Lab at the same time. That way we can configure the switches at the same time here. I just have to I got to remember to add more interfaces to these switches, because by default in Cisco Modeling Lab, these switches, they come default with only four actual interfaces. We gotta add some more. That way we can create proper Ethernet channels here. All right, so that's good. Add some more to that one. Cool. Let's go over the config. Let's go over the node information, and let's say distro switch. Save that. And call you switch. All right. So we got distro. We got main. Let's add a couple of PCs in the mix. All right. What I'll do, let's add a hub. Let's add a hub into the actual ingredients here. I'm gonna just call you hub. Just so I can hook up multiple PCs to this afterwards without running into other issues. Okay. All right, we're gonna say VLAN 10. VLAN 20. And VLAN 30. Keep it simple. All right. Let's get these switches fired up. We'll leave the PCs and the hub off right now. We're just worried about, because it's gonna take a minute for these switches to actually boot up. So all right. Yeah, so it's gonna take these a minute. Remember, these are virtual images, guys, so these actually have to boot up. As you can see, this right here down at the bottom of my screen, this is actual CPU usage. So this is actual physical CPU usage, memory, and then disk usage as well. So this is all running virtualized images, guys. So it takes about a minute to actually boot these up here. So, all right, let's go over to the actual chapter, and we'll gonna review the last part of this chapter, okay? All right. VLAN routing with layer 3 switch routing ports. When layer 3 switches use switch virtual interfaces, the physical interface on the switch acts like they always have as layer 2 interfaces. That is, the physical interfaces receive Ethernet frames. The switch learn the source MAC address of the frames. The switch forward the frames based on the destination MAC address. To perform routing, any Ethernet frame destined for any switch virtual interface MAC address triggered the process of the layer 2 switching logic, resulting in normal routing actions like stripping data, link header, and making routing decisions, and so on. So again, what that is pretty much implying, what's up, baby? How we doing? I have to use audio only. I can hear you. So you can hear me. Let me give a hug out to my lady. There we go. There you go. There's a virtual hug for you, baby. A virtual hug for my baby. All right. Yes, I'll stay on, LOL, while still at work. I'm on Bluetooth. I love you, baby. It's so awesome. All right. So, again, what that is stating is that the physical, not the SVI. So the physical interfaces on the switches still act as layer 2 interfaces. Okay, so when they receive frames, okay, when they receive frames, they still love your face. They still add the source MAC addresses to their MAC address tables, and they still forward those frames out to destinations. That's out to ports related to the destination's MAC addresses. Okay, all right. But what it's stating though, if the frame, it stays right, the switch learns the source MAC address and frame, the switch forwards frame based on the destination MAC address. To perform routing, any Ethernet frame destined for any switch virtual interfaces, MAC addresses trigger the process. So when a frame comes into the switch, again, it still does, so when the physical ports still do layer 2, all right, logic, okay? But when a frame comes into the switch, okay, destined, okay, it has to be destined for the switch virtual interface. So if it has a IP, so if it's going, so say it's destined for an IP address that is assigned to the switch virtual interface, okay, when that packet comes in to that switch's port, okay, that's what triggers the layer 3 logic then, okay? If that frame wasn't destined for that switch virtual interface, that switch wouldn't imply layer 3 logic to that frame. It would just still continue to apply layer 2 logic to that frame, okay? All right. So that's just how, that's the difference between a layer 3 switch and a layer 2 switch on the type of logic that it handles and applies to itself right there. All right. All right. Alternatively, the layer 2 switch configurations can make a physical port act like a routing port interface instead of a switch interface. To do so, and that's what we're going to be doing today, to do so, the switch configuration makes the port a routed port. All right. On a routed port, the switch does not perform layer 2 switching on that frame. Instead, the frame arrives in the routing port, triggered the layer 2 routing logic instead. So that is the difference between what we had done up in here. Okay, that's the difference between what we did here. Okay, and then that's the difference of what we're going to be doing down here. All right. So instead of the frame arriving the routing port and triggering the stripping the incoming frame, Ethernet header and trailer, making the layer 3 forwarding decision by comparing destination IP addresses to routing tables, adding a new Ethernet frame, a new Ethernet data link and header trailer to the packet, forwarding the packet, encapsulating the new frame. The third major section of the chapter examines routed interfaces as configured on Cisco layer 3 switches, but with a particular goal in mind to also discuss layer 3 Ethernet channels. The exam topics do not mention routed interfaces specifically, but the exam topics do mention layer 3 Ethernet channels, meaning layer 3 Ethernet channels. Okay? Kind of just said the same words over and over again, but that's it. All right. You might recall that Chapter 10, RSTP and Ethernet channel configurations discuss layer 2 Ethernet channels. Like layer 2 Ethernet channels, layer 3 Ethernet channels also treat multiple links as one link. Unlike layer 2 Ethernet channels, however, layer 3 Ethernet channels treat the channels as routed ports instead of switch ports. Okay, so this section first looks at routed ports on Cisco layer 3 switches and then discuss layer 3 Ethernet channels. All right, implementing routed interfaces on a switch. When a layer 3 switch needs a layer 3 interface connected to a subnet and only one physical interface connects to that subnet, the network engineer can choose to use a routed port instead of a switch virtual interface. Conversely, when the layer 3 switch needs a layer 3 interface connected to a subnet, and many physical interfaces on a switch connect to that subnet, a switch virtual interface is used. Virtual interface forwards traffic internally into VLANs so that the layer 2 logic can forward the frame out to any port in the VLAN, and routing ports cannot. Okay. So to see why, consider the design in the figure, which repeats the same design from the figure used in the switch virtual interface example. In that design, that gray area on the right represents the switch in its internals. On the right of the switch, at least 2 access ports sit in both VLAN 10 and VLAN 20. However, the figure shows a single link from the switch to the router. The switch could configure the ports as access ports in a separate VLAN, as shown in VLAN 30 in the example. However, only one switch port is needed. The switch could configure that link as a router port shown in the figure. Okay, so that's all. It's pretty much. So it's saying routed interface, not a VLAN. So an actual, not a VLAN. Okay. I'm learning so much. It's all hoobity gobbly to you, huh, honey? I love my wife. All right, pay attention, woman. You might learn something. All right, enabling a switch interface to be a routed interface instead of a switch interface is simple. Just use the no switch port subcommand on the physical interface. Now the no this was the command last night that did not exist in Cisco packet tracer. Okay, so I could not. Oh, woman. I could not on that, at least on that switch that I was using in Cisco packet tracer. I could not use. You better recognize. She's gonna beat me up when she gets home. I could not use the no switch port command on that. On the sub interface command, obviously with Cisco packet tracer, not everything exists on it. All right, maybe I was doing something wrong, but we're gonna find out tonight with Cisco Packet Tracer. And let's just check. All right, so my devices are up now, so they're good. All right. Cisco switches. Cisco switches capable of being layer 3 switches use a default of the switchboard command to each physical interface. Think of the word switchboard for a moment. With that term, Cisco tells the switch to treat the port like a port on a switch. That is a layer 2 port on a switch. To make the port stop acting like a switch port instead of act like a router port, use the no switchboard command. Okay. Once the port is acting as a router port, think of it as a routing interface. That is, configure an IP address on the switch port as implied in the figure. Shows a completed configuration for the interface configured on the switch. Note that the design uses the exact same IP subnet as the example that's shown in the switch virtual interface configuration, but now the port connected to the subnet 10.1.30.0 has been converted to a routed port. All you have to do is add the no switch port command to the physical interface in the IP address on the physical interface. Okay. So here it is, just IP routing, assigning creating some VLANs, and then again, so now we're acting like a router with the interface and the no switch port. Okay, so we're acting now. This is very familiar to how no, I did not want to do that. We add a IP address to an actual router's interface. Okay, all right. So, all right, once configured, the router interface will show up differently in the command output in the switch, in particularly for the interface configured on as a routing port with an IP address like 8 gigabit 0-1, the previous. Show interface, we got some show commands, show interface status, show IP route, show interface, number switch port, and then here's just some of the information here. So you can see how it changes it to routed, okay? Routed, all right? We can kind of play around in Packet Tracer, okay? All right, let's play around in Packet Tracer real quick. All right, I'm just gonna grab a one-off computer. I'm gonna call you Mr. Random. Mr. Random. All right. All right. Let's dive into some configurations real quick to get this rocking and rolling. All right. I just changed that awful host name. I'm gonna just call you distro. All right. So let's do this. Let's go into interface gigabit 0-0. Let's give it the no switch port command. There we go. All right. So there we go. Now let's give it the IP address. All right. IP address. We'll say 10.0.0.1, 255.255.0. All right. We'll give it the no shut. All right. Let's say IP DHCP pool net random. All right, I'm gonna say network 10.0.0.0 255.255.0. Let's say default 10.0.0.1. All right, exit. All right, let's write that real quick. Now let's do a do show interface. Let's show wrong. What do we got? We got show interface status. Oh. All right. So just like in the textbook, all right, what we got on gigabit 0-0, we changed that to a routed port. Okay, so we changed that to a routing port. It's not a VLAN anymore, as you can tell. And the VLAN, it's not associated at all with any actual VLANs here. It's an actual it's its own routing port now. All right, now if this is correct and this should work, what should happen here is let's boot up this PC. All right, boot up this PC and let's see if it's acting as a router now. Yeah, we'll even well, I should have attached the hub to it. It's alright. It's alright. So, all right. So look at that. So it's acting as a routing port. All right. So we have an IP address now. Okay. Now let's just see if we can ping. We could see if we can ping that interface. And look at that. So already we've already proved that a layer 3 switch, all right, could solely act. So that gigabit 0-0 is an actual routing port. Okay. It is no longer performing layer 2 information. It is strictly layer 3 now. So it's performing IP level layer 3 networking functions, logic. All right. All right. Pretty cool. Pretty interesting. And that's one thing we couldn't recreate in packages. Again, I might have been doing it wrong last night. It was getting pretty late and I was trying to rush. I was rushing to try to get to work. So, well, trying to get ready for work. That's it. All right. So we've done that. Okay. Now we can kind of, let me, you know what? I want to, let me shut this down. I'm going to undo this link. All right. I'm going to add another command. Info. They're going to be random hub. They're going to be two. Fire this up. This is yeah, those are just hubs, so they don't take too long to fire up. Now again, I just want to just prove again that the switch is performing layer 3 information. Well, layer 3 logic. How's that? Seriously. I have a great tendency of breaking these things in Cisco Model Lab. I'm a pro at breaking them. Trust me. So we got an IP address there. And now let's see what random one should get an IP address as well. And then again, we should be able to have communication between both. Oh, I broke it again. I love it when it breaks. Man, awesome for awesome. The awesomeness of virtualization sometimes. You can break things. So I'm a pro at breaking Cisco packet tracer. If anybody out there works for Cisco DevNet, you guys should hire me. Because I can test your your packet tracer your Cisco Model Lab program out and find new and interesting ways to break it all the time. Ah! Alright, that's not gonna work. Epic. I really can't believe it's breaking like that. Man. Yep. Alright. I think I just completely broke packages. Not packet tracer. Cisco Model Lab. Let's try that again. A beepity boppity boop. Will it work at this time, huh? Will it work at this time? Oh my goodness. Yeah, I broke it. Yep, everything's broken. Yep. That's no good. Yep, everything's broken now. Ah. Let me exit out of this. Let's go back in. Hey, there we go. Maybe it won't be broken this time. Hey, I got a console. Woo! Man, that was tough. Holy guacamole mole. Alright. Alright, let's see if we can ping 10.0.0. What is the other one? 2? Is it 2? Probably not 2. 3 or something like that, right? 3. All right, very good. All right. We're back in business, everybody. All right. So that's good. So that's all set. All right. Let's go back over to the chapter here. My hat back on. All right. Let's continue to review. All right. So we reviewed the routing port. So we reviewed that. So with the two options, switch virtual interfaces and router ports, which one, where should you use? For any topology with a point-to-point link between two devices, that's doing routing, a routing interface works well. Okay. Any point-to-point link, okay, point-to-point layer 3 distribution core, okay. So again, what it's stating is for any topology with point-to-point link between two devices that do routing interfaces work well. All right. Shown in the example of where a switch virtual interface and where a routing port is typically ports is in a typical core distribution access design. In the design, the core 1, and core 2, and distribution D11 through D14 switches perform layer 3 switching. Okay, so what it's stating is these devices inside of this pretty much like infrastructure area here, this core area here, these are doing layer 3 logic, while these devices over here are performing layer 2 type logic. Okay. All right. All ports that are linked directly between layer 3, between the layer 3 switches, can be configured to be routing interfaces. For VLANs for which many interfaces access and trunks connect to any VLANs or switch virtual interfaces, makes sense because switch virtual interfaces can send and receive traffic out multiple ports on the same switch. In the design, all the ports on core 1 and core 2 will be routed ports, while the 4 distribution switches will have some ports, will have some routing ports, and it will have some switch virtual interface ports. So again, what it's stating on these interfaces here on these switches, these interfaces here on these switches, these would be the switch virtual interfaces, okay? And then these interfaces on this side will be the actual routing ports, okay? All right, implementing layer 3. That's what we're going to be getting into tonight. This is what I really want to get into. About my macaroni. Cold macaroni. I love it. All right. So far, this section has stated that the routing interfaces can be used with a single point-to-point link between pairs of layer 3 switches, or between layer 3 switches and switches in a router. However, in most designs, network engineers use at least 2 links between each pair of distribution and core switches, as shown in the figure. All right, 2 links between each distribution and core. All right. While the individual ports in the distribution and core could be treated as a separate routed port, it is better to combine each pair of parallel links into a layer 3 Ethernet channel. Without using Ethernet channel, you can still make each port on each switch in the central of the figure a routed port. It works. However, once you enable a routing protocol, but don't use Ethernet channel, each layer 3 switch will learn the 2 IP routes with the same neighboring switch as the next hop. One route over one link, another route over the other link. So pretty much what it's stating is, yeah, you can go ahead and configure all these multiple interfaces that are redundantly hooked up to each other as their own separate routed port. But say if you implemented OSPF, that's just going to create, I don't know, I guess it's just going to create it's going to create like a messy type of routing table where there'd be too many routes to get to the next hop. And you're not going to be balancing properly over the actual, the multiple links, the redundant links that you have set up in this type of topology. All right. All right. Using a layer 3 Ethernet channel makes more sense with multiple parallel links between the 2 switches. By doing so, each pair of links act as one Ethernet layer 3 Ethernet link. So each pair of switches has one routing protocol neighboring relationship with the neighbor and not 2. Each switch learns one route per destination per per link. Okay, and 2. iOS then balances the traffic, often with better balancing than the balancing that occurs with using of multiple IP routes in the same subnet. Overall, layer 3 Ethernet channels approach work much better than leaving each link as a separate routed port and using layer 3 balancing. Whew. All right. Compared to do what you have already learned, configuring a layer 3 Ethernet channel takes only a little bit more work. Chapter 10 already showed you how to configure Ethernet channels. This chapter has already shown you how to make a layer 3 routing port. Next, you have to combine the two ideas by combining both Ethernet channel and routing ports configurations. The following checklist is steps assuming static definition. Okay. All right. So configure the physical interfaces as follows. In the interface, add the channel group number mode on command to add it to the channel. Use the same number of all physical interfaces on the same switch, but the number used, the channel group number can be different of the two different names. All right, add the no switch port command to make sure that each physical interface. So add the no switch port command to make each physical interface a routing port. Step 2, configure the port channel interface. Use the interface port channel number command to move to port channel configuration mode for the same channel number configured on the physical interface. Add the no switch command to make sure that the port channel interface acts as a port. iOS may already have added this. Use the IP address. Okay. All right. Let's dive into this. All right. Stretch. Ooh, stretch. Give me 1 second, guys. I'm gonna go grab a drink real quick. Hold on, Betsy. Joe. All right. Got a drink. Just needed a drink real quick, guys. That's it. Sure. Ah, dribbling. Oh, my baby's still there. That's what I'm talking about. Let's get to it, baby. Yeah. I think you guys need some entertainment here. I don't need you guys falling asleep on me. Boom, 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 boom. Boom, 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 boom. Let's get some music up in here. We're getting techno, baby. We're getting groovy up in here. We're getting freaky. Oh, yeah. All right, let's do some cyber configuration. Oh yeah. Oh, whoa. Back up. Back up. Man. Stay there. Stupid, right? All right, let's do it, folks. All right. So what we need, what we need to do is this. All right. Let's do. That way it's not double feeding. All right. So what we're going to do. All right, so let's do this. Where are we at? We're on the PC. I don't want to be on PC. Yeah. Switch. I'm loving. She's rapping. My baby's rapping pallets right now. Ah. Give this a second, guys. Not bunning. I'm on. Stop translating. All right, there we go. All right. So, interface. What channel? 1. All right. So we're there. I'm gonna say no switch port. All right. We're gonna give it the IP address of give it the 10.0.10.1 5.5.0. Give it the no shut. All right. All right. Now we have to assign links to that. All right, let's take a look at what we got for interfaces. So let's do 0.1 and 0.2. All right, so let's do int range gigabit 0-1 to 2. Okay. All right. I'm going to say no switch. All right. Then we're going to say no IP address. All right. Now this is where we're going to assign it to the channel group. So channel group 1. All right. So we're going to say why is my thing lagging? I don't know why. I gotta dig into that. Let's say mode. Let's say desirable. Post name real quick to main. All right. Now I want to see. Let's exit out of here. Go. To show Ethernet some. Channel. All right, so we have our Ethernet channel. So if I go into here and I just switch it to, is it auto? Perfect. Okay. I put that channels. What I put is desirable, so auto. All right, so let's go to interface range gigabit 0-1 to 2, and we're gonna say channel group 1 mode auto. All right, that should have just brought up. Let's check it out now. All right, so now we have our port group dynamic. So what we did was we dynamically we dynamically had it configured on the other switch. Okay. All right. All right, so we're good. We're up and running now. Well, that's cool. All right, so that's up. Now let's go back to the let's check out the it is the interface status now. All right, so let's do a do show interface status. All right, so cool. Look at that. All right, Cole, we're up. We're cooking with gasoline. So we have our port group. All right, so our port group. Let me get. Nice. All right, so our port group 1. All right, it's coming up as routed. So our interfaces, these two interfaces right here, gigabit 0-1 and 0-2, they are in port group 1, okay, as routing as routed interfaces now. Okay, as routed interfaces. Okay, all right. So let's do another port group. Let's create another one. All right, let's do that again. So let's do interface port channel 2 now. Okay, I'm gonna say no switch port. All right, no switch port. Remember, no switch port turns it into a routing port. Okay, let me take that off my head. Goofy. You guys can look at does multiple Joes. Enough of that. All right. All right. All right. Now let's move into. Let's do gigabit 1 and 1 and 1 2. So let's do the. All right. So let's do interface range gigabit 1-1 through 1-2. Okay, we're gonna say no switch port again on those. All right. Oh, yeah. You know what I forgot to do? Forgot to assign it an IP address. All right, let's move back to the interface. Port channel. I didn't give that an IP address. 10.0.20.1 0 range gigabit 1-1 2. Okay. No switch port. P. Okay. And then channel group 2 mode desirable. Okay. All right, because we're going to be using PADGE, which is port aggregate group protocol. Port aggregate group protocol, and I'll get you the terminology. I'll get you the definition on that. So port aggregation protocol, okay, is a messaging protocol defined by Cisco that enables two neighboring devices to realize that they have multiple parallel links connecting to each other, and then they decide which links can combine into Ethernet channels. Okay, so that's what we're using. So we're using PADGE. Okay. Okay. That's gonna go down. We're gonna connect 1, 2, 2. Okay, now let's do interface range gigabit 0-1 to 2. All right, and we're gonna say channel group 2 mode auto. All right. look at that. So we're up. So if we do a show Ethernet summary now, we should have our 2 port groups, in which we do. So we have our 2 port groups. All right, they're both using the port aggregation protocol, which is a Cisco proprietary protocol. Okay, let's do a show interface status. Perfect. So now we're showing our port group. So now we have our multiple port groups. Here's port group 2 now. All right, and then we're also showing that we have multiple. All right, we have the other 2 as routed ports. Okay. Hey Joe, come here real quick. Joe, come here.
What?
Hey.
Yeah?
You're gonna go upstairs right now and ask Maxwell why he's screaming like that.
Okay.
Crazy kids. All right. So let's exit. Let's do right. Let's write these configurations, guys, before we get ahead of ourselves. Do show IP interface brief. I want to take a look at our IP addressing here. Hey.
He said because somebody calling him a clown.
All right. This is why I don't want him on it. Tell him he's all done for the night now.
Okay.
All right. That's why I didn't want him to have the headset. Nobody wants to listen to me. All right. So we have that. So we're good. Now let us. All right. Let's do this on the distro switch IP. Yeah, IP DHCP. Call it net 10 network.
Maxwell said he won't turn it off.
Hmm.
Maxwell says he won't turn it off.
Okay.
Okay.
DHCP.
Yeah.
I'm gonna call it net 20. Exit. All right, so that's cool. Let me just do a show route. Want to look at our routes real quick, see how they're looking. All right, so we're looking good. My question is, do this correctly now. to do this correctly the way I want to do it. Do this the way I'm kind of thinking. Yeah, that's what we did. Now I wonder if there's sub interfaces on these port groups. So if I was to do int PO1 1.1.10, is that something? No. It is. Oh. It is. It is. It is. It is. It is.
So what kind of computers are you doing now? Random 1 and random 2. While on 10, 20, 30. Wow. So you're trying to connect those two computers to those three?
Sort of, kind of. So I proved something going this way. So this was just a
Random hub.
yes. This was just a random demonstration of a certain configuration. Now I'm trying to do another configuration
To connect to while 10, 20, 30.
Yeah.
Just trying to figure out the code
Yeah.
to connect it. I mean, why don't you use codes like random 2 and random 2 and hub? So random 2 to hub to connect those three computers, and I think it will work. And that's a good idea because they're all connected.
Right.
So if random 2 is connected, a hub will be connected, then all those three hubs will be connected. Did you try that idea? Not yet?
Not yet, Clapton. Not yet.
Good accent. You thought about it?
Mm-hmm.
Maybe you should try that. See how it goes.
So, okay, so what's this? Encapsulation, .1Q. All right, I have an idea. The maximum interface does not support these giant frames. Zero dot 100. 1.5.25.25.0. All right. Oh, this is gonna get confusing. This is gonna get confusing. Interface PO1 20 encapsulation Q 20 IP address 10.0.200.1 but and then we'll make, so we'll do interface PO 100, okay, and then we're gonna call that no, let's exit interface PO 1. All right, I'm gonna say encapsulation .1Q 1 native IP address 10.0.10.0. What do I get for address? The addresses 10.0.1.1 5.
You know I don't like you.
Oh man, hold on. I'm gonna get confused real fast on what I'm trying to do here. Trying to do something that should work. It should work. Let me just see what I got going. So I got 3 and 1 going to that hub, right? 0 dash gigabit 0 dash 0 dash 3 and gigabit 0 dash 1. Oh, I need to make VLAN. So VLAN 10, VLAN 20. All right. Let's go to interface. Is this gonna work? Is this not gonna work? Interface gigabit 0 dash 3 switch port access. This ain't gonna work. I can tell you this ain't gonna work. No, it's not gonna work. Ah! It's not gonna work. I'm not thinking about this correctly all of a sudden. Oh, what am I thinking? I would have to have separate hubs. Yeah, and that's what I need to do. Yeah, I can't just do it all at once. It just won't. It will not work that way. But then on this switch here, on interface, interface PO1, switch port, trunk, encapsulation, U, switch port, mode, trunk. Alright. Now, I'm gonna hook up the VLAN 10 PC to this. We'll see if we got it to work. If my logic is sound, then this should work. This should be a successful. This should be a successful lab if this works then. I'd be pretty stoked if it worked too. Honestly. I'm like so anticipating this thing turning. Come on. No, didn't work. What happened? Did it crash? Oh, no way, dude. Ah, it crashed. Wow. Huh. I crashed it all. That's funny. That is freaking hilarious. You know what? Let's do that lab again. Yeah, I crashed it. Oh, okay. Got it. That's funny. I crashed that whole entire lab. Try that again. So we need one switch, two switches, right? And then we need hubs. We'll make two VLANs and one PC apiece. Need VLAN. Hopefully my logic is sound this time. I don't make mistakes. That was pretty epic. They crashed that all.
Hey, Daddy. Look, guess who's on the phone?
Yeah, I know.
Mommy.
Alright, let's try this again without.
In our stream. Go to your stream.
Come on! I ain't got all day to wait on you. I gotta get ready for work tonight. Nah. I'm having fun with this lab though. I prefer labs that challenge my my intellect here. Well, I guess everything challenges my intellect because I'm not that smart, but I guess challenging my configuration capabilities, you know. So I'm kind of pumped up. that it's doing that. So yeah. Again, appreciate everybody, you know, sticking around. I don't know how many people are left. Looks like there's only one. There's only one. There shall only be one. Which is, how we at? Did I break you two forever? So we have to think. So when we do this time around, we have to put our minds in the mindset of thinking about that switch as it is a router now. Those port channels as router interfaces. Okay. I guess I didn't need to make. I guess I didn't because we'll only use one this time. We'll only use one this time. That way I don't blow things up. All right. And then we'll see what we can do. Again, if I don't grenade everything. Come on, switchies. So the good part is we finished. We're through chapter 17 now. Next is the very last part of part 5. So we're pretty much through part 5. chapter 18 is a fairly short chapter, and it's just going through some troubleshooting. I just want to get this last configuration down. There we go, finally. Holy schmoly. All right, so let's create a port channel. Let's get this configured up. Host name. Go change that host name. Distro. All right. Now, let's move into the interface port channel. Interface port channel 1. We're just gonna make interface port channel 1. We're gonna say no switch port. Okay. We're gonna give it an IP address. All right. I'm gonna give it an IP address, right? I'm gonna say 10.0.0.1.5.5.0. Shut command. All right. Then we're gonna move into the interface range, gigabit 0-1 to 2, right? No, it's 0 to 0. 0 through 1. Okay, we're gonna give it the no switch port command. We're gonna give it the no IP address command. Okay, all right. Then we're gonna say channel group. Channel group mode. Channel group 1 mode. Desirable. All right. And host name. Interface range gigabit 0-0 through 1. Channel group 1 mode auto. We got that now. Now let's move into interface. Port channel 1.1. We're going to say encapsulation .1Q 1 native. All right. We're going to say IP address 10.0.1.1.25.25.0. All right. Then we're going to say interface PO1.10 encapsulation .1Q 10. All right, IP address 10.0.10.1 5.5.0. All right, interface PO1.20 encapsulation .1Q 20. the address 10.0.20.1.5.5.0. All right, IP DHCP pool net 10. Network 10.0.10 0 to 5.5.0 default 10.10.1 DHCP pool net 20 network 10.0.20.0.5.5.0 default 10.0.20.1 exit. Right. All right. Now, if we're thinking about this switch as a router now, that's how I would have configured a router on a stick. Let's do a run. Let's look at our configuration.
I got a nerf.
Got the Nerf gun. You ready for war?
I'm ready for war, baby.
So we have our port channels. We have our sub interfaces on our port channel set up. Negotiation auto. Remember, these two are on our port channels: gigabit 0-0 and 0-1. All right. All right. Now let's do a do show Ethernet Ether channel. Let's do a do show interface. PO1. All right. Let's do a do show IP route. We have our routes, our ports and everything. Okay. Now this is what broke it last time. And is it because I'm doing it the auto configuration? I don't know. Oh, I hope this doesn't break it again. If it does, then I know I'm doing something wrong. So let me just do a do show Ethernet. Let's just save this configuration before I break everything again. Just in case I gotta roll this back again. All right. Do show. All right, so that's good. Now, if I'm thinking again, if I am looking at this as this is how I'm doing the router on a stick configuration, then I would say that the port channel would be my trunking interface. My other one. So let's just make some VLAN. So let's just make VLAN 10 and what are my interfaces? Gigabit 2 and gigabit 3, okay. Switch port, access, 10, interface, gigabit 0-3, switch port, access, VLAN. That does that. Now what broke me last time, let's just do this again. Let me just do this first. Let's out of curiosity, I just want to see what happens first. Before why isn't it giving me the option to delete that? You didn't give me the option to delete these stupid things. Not giving me the option right now. Huh. They're changing the way it looks now. Instead of famous, it's Tamus. Want to become Tamus? Fucking bots. Speed that, right? Let me, instead of doing it to the port, man. Again, I don't know if this is gonna break it again. So if I do an interface gigabit 0 dash 1, oh, interface range gigabit 0 dash 0 to 1. Switch port mode from yeah, I don't know, guys. Getting confused here. Ah, broke it again. Yeah, we watched it happen that time. Alright, so I can't do that. That's just not happening on these. I gotta work on that configuration, I guess. I crashed it again. Alright, well. We'll have to recap on this one, guys. I gotta get ready to get ready for work anyway, so back to the dash. So, to give you guys a recap, we'll pick back up tomorrow, and we'll most definitely finish off chapter 18. If you guys don't mind, I want to try something that I haven't done yet. Give somebody a shout out. How do I do this? Hold on. How do I? Thingy. Trying to figure out how to do this. Oh, what did I do? Hold on, stick with me just for one more minute, guys. Stick with me. How do I do this? Hold on. How do I do this? Trying to figure out how to raid. What do you raid on? So this should do it. Okay. And I'm gonna do. This how to do it. Let's see if this works, guys.